Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So today's challenge is a really easy one. So let's try to understand the problem at first. Sort matrix by diagonals. You are given an n cross n square matrix of integers grid. Return the matrix such that the diagonals in the bottom left triangle, including the middle diagonal, are sorted in non-increasing order, and that is in the descending order, and the diagonals in the top right triangle are sorted in non-decreasing order, it means in the ascending order. So what we need to do is that if we are given a grid something like this, a 3 cross 3 grid, let's say it's given to be 1 7 3 9 8 2 4 5 6, and the output should be something like this. If you try to visualize it, I will just draw it for a better understanding. 1 7 3 98245 98245 So you need to focus on the bottom triangle, lower triangle, lower left triangle, okay, and also this upper triangle, and you must make sure that every diagonal wise element, so this diagonal wise element is sorted in decreasing order, it means in descending order. So you see the elements are now 186, so if you sort it in descending order it will be 861, okay. So in the new matrix which you will be outputting, okay, so the elements of the diagonal will be this, and you see this is already in the descending order and this is also there. So 9 and 5 and 4 will be this thing, and this upper triangle, the whole upper triangle should be sorted in increasing order. So you see 7 2 is decreasing, so you sort it in an increasing order, it will be 2 7 and it will be 3. So your final matrix will be something like 8 2 3 9 6 7 4 5 1, okay. So you got this, I guess you got it, 823 967 451. That is what you need to output. So you just need to simulate how to traverse through the diagonal elements, and that is all you need to do in this problem. And the constraints are really less. Okay, I don't know why this constraint they have given so less, but yeah, I hope the question as it is the problem statement is now clear to you. And so all you need to do is that what you can do is that you when you have a matrix, okay, you have an n cross n matrix, so it is a square matrix. Let's say this dimension is given traversing by I and this is traversing by j. All you need to do is that you iterate through the diagonal elements. So you store the diagonal elements in some array, okay, you keep storing, you traverse in this manner and store each one of every of these diagonal elements, sort it and again replace them in the grid, okay. Then again you go to this diagonal, sort it and again replace them in the grid, okay. Again you do the same thing for this one also, you reverse sort it, right? So for the lower triangle you need to reverse sort it, and for the upper triangle as you are iterating you should sort it, okay. Okay, so I hope it is clear to you, okay. But you need to just understand that how to iterate through the upper triangle and the lower triangle matrices. So the only question is that how to iterate separately. So now consider the case of the lower triangle only, okay. I am considering the case of the lower triangle. How will you iterate it in that way? So you see, if you are given it any portion of the grid, let's say grid I comma j, okay, you need to grid I comma j, let's say you are having, and you need to go to the rightward diagonal, because your way of iteration, no matter in the top left or in the lower triangle or in the upper triangle, your way of iteration is always like this, right? Your way of iteration is always like this. So I hope you understand that if grid I of j, you are in a position of grid I of j, your iteration, next iteration will be something like grid I of I plus 1 j plus 1, okay. So I hope you understand, and it will go on like this. It will just simply go on like this. So in what element in the lower triangle, if you see, here you are starting with 0 0, okay. You are starting with 0 0. You are going to 1 comma 1. You are going to 2 comma 2, and all the way till n comma n, okay. And you see here also what you are doing in the second element. You are starting from what? You're starting from 1 comma 0. I is 1 and j is 0, and then you are going to something like, you are just keeping adding 1, okay. So you are something like 2 comma 1, and then you are something like 3 comma 2, and so on. Similarly here you have 2 comma 0, and you are just going something like 1 3 comma 1 4 comma 2 and so on, okay. So in a general case, if you see in a general case, you are in the lower triangle. For the lower triangle, if you talk of the general case, you are starting from I comma 0, right? You are starting from I comma 0. So you can say that you are starting from I comma 0, and you are traversing something like I plus j comma j. Okay, so you are adding the same thing first. So what I want to say is that you are in a general case, you are starting from I comma 0 and adding 1 to both of them. If you are going in the, I mean, in the lower right manner, you are always doing something like this: I plus 1 1, I plus 2 2, in this way, right? So in a general case, your way of iteration is I plus j j. Okay, and this definitely both of these dimensions should be less than n. So what you can do is to have a simple loop. Okay, so what you can do, you can have a loop where I goes 0 to n, and for j it goes 0 to I plus j. This I plus j should be less than n. Okay, this should also be less than n, and that is the harder constraint here. And what do you do is that you can simply store, if you have a vector here, you can simply store vector dot pushback. Okay, what you can do, you can simply store it like vector dot pushback, and you can store grid of ij j. Okay, I hope you can understand this easily. uh, I just found out a pattern of traversal of this lower triangular matrix. Okay, this is the way pattern. Okay, this is the observed pattern of traversal in lower triangular matrix, lower triangle. Okay, so I hope you understand it. It is quite easy. And then in another loop, you can just in another loop from J. Okay, you can easily replace the grid of Ij. You can simply replace the grid of I plus jj, whatever the way you are doing, by vector of j. Okay, I hope this is very simple for you for understanding at least, and it is not at all difficult. It is not at all difficult. All you need to do is observe this pattern. Okay, and in order to observe this pattern, you don't need to do anything special, right? You just write what is the however way it is just following. Okay, so I hope you get it easily. And if you talk about the upper triangular matrix now, it is also very simple. So if I talk about the upper triangular matrix, you see, you start with this row, right? And so first one is definitely something like 0 comma 1. Okay, and this is starts with 0 comma 2 all the way till 0 comma n minus 1. So in a general case, what you will be doing is that you will be starting with 0 comma j. Okay, you will be starting with 0 comma j. So general criteria for upper triangle, what is the general thing? And you will be having something like 1 comma 2 2 comma 3 and so on. So you will be having something like 1 j plus 1, 2 j plus 2, and so on. So you can say that you are having I j plus I. So for using this loop, you need to have the inner iterator as I. Okay, so instead of I j, you first iterate through j. Okay, and then inside you keep an I. Okay, and you do for I plus j less than n in the same manner. Okay, so I hope you easily understand. It was you need to iterate in the fashion of I j plus I, and here I plus j j. Okay, so I hope you understand this. As I will code, things will become more clear, and this is just a pattern, right? I hope you understand this. Okay, so let me just quickly code it out. uh, so far we have discovered patterns for traversal in the lower triangular as well as in the upper triangular matrices, and we just need to iterate through the matrices, sort or reverse sort, whatever it's told in the question, and just replace those elements in the grid. That will be all for this problem. So if you need to have a single dimension only, because both the dimensions I and j are of the maximum length n, is given to be a square matrix, right? So one thing you can do is that you traverse through all the i's, and you also traverse through all the j. Okay, so I j, you can call it I plus j to be less than n, and j plus plus. Okay, and you need to have a vector here definitely. So you have a vector vc. What you can do is that you can simply into pushback vector dot pushback grid. So what was the general formula which we derived? I plus jj, right? So you can have it to be I plus j and j. You just push these elements into a grid and you do the same thing again. Not the same thing. Once you push it, what you can do is that you can reverse sort it. The lower triangular needs to be reverse sorted, right? So instead of begin, you can do r begin and r end. Okay. So I hope it is clear to you. Okay. So what do you need to do is that for this thing right now, you need to replace all the elements of grid I plus those elements which you just sorted them. Okay, you just need to replace them by vector j. So whatever values you just sorted, you just do it. Okay, you just do it. It's quite simple and easy. And for the lower triangular, what you need to do, as I just told you, you need to start with j. Okay, and j will be starting from 1 instead of 0. Why? Because the first element, instead of being 0 comma 0, we have in the upper triangle to be 0 comma 1, and in general it is 0 comma j. Okay, so j will be iterating in this case, and I will be the inner variable which we would want to iterate. Okay, and what we would like to do here is that I and j plus I. Okay, I and j plus I. I hope this is the thing which we just derived. I and j plus I is the thing. Okay, so that is what you will be doing. So instead of r begin, so I will just do vector dot begin vector dot end, and this will be I instead of j, and this will be I j plus I. Okay, so I am just taking out the elements in the lower triangular matrix through this loop, and taking the elements in the lower upper triangular matrix in this loop, and I am just whatever is told in the question, you just sort it in descending order for the bottom left triangle. Okay, I sorted it in descending order and just replace the elements, and here also I do the same thing. I just sorted in ascending order and then replace the elements. So yeah, I guess that was quite simple. All you need to do now is just return the grid after you have replaced all elements. Okay, so if you try to run this code and check if there are any error. So yeah, there is a compilation error. If you see, no member name sort. Okay, so why this is happening? Okay, so you see, all you need to do is sort, right? Or there's nothing called vector of sort. So yeah, that was error. Okay, so if you try to submit it now, will it get accepted? So yeah, you see it got accepted, and it is also having a decent runtime complexity, only 3 milliseconds, and bits is also 92.18%. If you try to analyze the time complexity, you will get it to be n square log n. Okay, so I hope that is simple, because we have in an n loop. For every n loop, I am doing an n log n sort, which is the worst case here. Okay, so for every n loop, if you are having an n log n sort, then n into n log n is your time complexity, which is nothing but O of n square log n. Okay, so I hope this problem was simple to you and you might have solved it on your own. Even if you did not, I hope the solution is now very clear to you. It is not at all difficult to understand. Okay, so yeah, that is all for this problem for today, and I hope your day goes really easy. Thank you so much.